My dear friends, welcome back to BSpice. In this session, we'll continue with OPC, Open Platform Communication. So this will be the video number 500, friends. Thank you once again for all your support, especially for the members. So without your support, we would not have reached this much, friends. This is the video number 500. So this is a milestone video. And what we are going to cover is very, very important aspects related to OPC. In fact, in the interview also, this kind of questionnaires will come. So we'll talk about the, what you call functionalities of OPC. We'll dive deep, in fact, and also at the same time, we will see the limitations also. And of course, we will see the future of OPC. All these we will dive deep. Okay. So let's get started. Okay. When we talk about the functionality, friends, one important functionality is a data exchange. OPC allow clients to access and retrieve data from server. OPC allows client to access and retrieve data from server, and server expose the data to clients. That is one of the important functionality, data exchange. OPC client can read the values of item exposed by OPC server. So OPC client can read the value of the items exposed by the OPC server, and OPC server can send updates to the client when the value of the item change. You got it? Yes. So this enables a real-time data exchange between the devices and the system. You got it, friends? So that is the data exchange. Second item, control. OPC allows a client to send requests to server to perform certain control actions or control the devices and systems connected to the server. I repeat again, OPC allow client to send requests to, the server to perform certain actions or control the devices and systems connected to the server. For example, an OPC client can send a request to an OPC server to start or stop a motor or to change the set point of a temperature controller. I hope this is clear, right? So that's about the control. Then third one, integration. OPC enables the integration of different devices and systems from different manufacturers. So that is the point, by providing a standard interface for communication. So this allows a OPC client and server to communicate with each other. Okay, regardless of the specific protocol or data model used by the devices and systems. So that is about the integration. Then number 4, monitoring. OPC allows a client to subscribe to the item exposed by the server and receive notification when the values of item change. So this is about monitoring. So this enables the OPC client to monitor the status and performance of the devices and systems connected to the server and take appropriate action if needed. So that's about the monitoring. Now we have a diagnostics. OPC server can expose diagnostic information such as error code, status messages through the items they expose. So OPC client can access this information to troubleshoot the problems and optimize the performance of the devices connected to the server. That's about the diagnostics. So these are the aspects related to functionalities, friends. Now we will see even though systems have its own functionality merits, always there will be a what do you call drawbacks. So that is why we will see the limitations. One of the limitation is on the performance. OPC server is a OPC is a client server model, which means OPC client send requests to OPC server and receive response from them. So because of this now, this can introduce some delay in the communication depending on the network latency and processing time of the server. Okay, friends. So this is one of the aspects. In an application that require very fast data exchange and controls such as high speed machine automation, OPC may not be a suitable solution. If you remember the previous section, we talked about this, friends, right? So I repeat again, in application that require very fast data exchange, like, motion control, all these robotics, all these, right? So this OPC may not be a most suitable solution. Then just think about it, what we talked, Ethercat, right? Yes. So that is one of the solution for having a very fast data exchange. You got it, friends? Good. So that is about the performance. Now, scalability. OPC is a client server model, right? Which means OPC client send data to OPC server and receive responses from them. So, OPC server can handle a limited number of concurrent connection from OPC client depending on their design and implementation. So there is a limitation how many client can be connected. Okay. So if the number of OPC client or the amount of data exchange between the client and server increases significantly, OPC server may become overloaded and may not be able to handle the load efficiently. So this is one of the issues, scalability. Okay. Now, security. OPC server typically expose the data and functionality to any OPC client, right, that can connect to them, which can pose a security risk if the OPC system is not properly configured and protected. But with proper configuration and protection, we can nullify this. So OPC client and server should be properly authenticated and authorized, and the communication between them should be encrypted. So that is the point, to protect against any unauthorized access and tampering. This is about the security. Then we have complexity. OPC can be complex control to implement and maintain, especially in large and distributed systems. So OPC client and server need to be designed and implemented carefully, taking into account the specific requirement and constraints of the application. Of course, we need to take care. So proper design and implementation can help to ensure the reliability, performance, and security of the OPC system. Then we have a compatibility. OPC supports different communication protocol data model, which make it more challenging to integrate the devices and system from different vendors that use different protocols and models. So OPC client and server may need to be customized or adapted to support the specific protocol and models used by the devices and system they need to communicate with. That's it, friends. These are some of the drawbacks. Okay. Now, what is the future of OPC? In recent years, OPC has undergone significant changes and update to meet the evolving needs of the industry. Okay. One of the most significant changes is the introduction of OPC United Architecture, that is UA, which is a new generation of OPC that provides a more flexible and scalable architecture for communication and integration. So OPC UA uses a service-oriented approach and based on web services and internet protocol, which allows OPC client and server to communicate with each other over a network using a standard protocols and APIs. I'm not sure whether you know about this API, friends. See, API is nothing but an application programming interface. It is a set of rules and protocol that allow different software application to communicate with each other. So basically this guy API act as a bridge between two systems. It defines how requests and responses should be structured, and it enables developers to use predefined function without knowing the internal logic. Okay. So basically, like, when we talk about the key characteristics, it provides a way for applications to interact. So basically for interface. Okay. So yeah, what are the type of API? There are many actually, like for example, web API, which is communicate over HTTP, RESTful, right? RESTful API. Yeah, something like this. So that is about the API. OPC UA also introduced new features such as support for security and encryption and the ability to expose complex data models and functionality to clients. So these are some of the developments, friends, and of course few more to add on. Looking into the future, it is likely that OPC will continue to evolve and adapt to the changing needs of the industry. So OPC UA is expected to become the main platform for OPC communication and integration, and it may be extended to support new technologies and applications such as Internet of Things, IoT, and Industry 4. Okay, so it is also possible that OPC will be integrated with communication protocols and standards such as MQTT, message queuing, telemetry transport, and also OPC XML to provide even more flexibility and interoperability. So overall, friends, OPC is expected to remain a key enabler for of communication and integration in the industrial automation industry, and will continue to play a critical role in improving the efficiency, reducing the cost, and increasing the reliability of automation system. So that's all I have, friends. I hope I have given the technical data related to OPC as much as possible. Thanks, friends. Thank you for your support. Keep supporting, friends. Without your support, we are nothing actually. So this BSpice is running only because of you guys. Thanks a lot. Hats off to all who supported, especially the members. Thank you very much. Take care. Bye bye. See you in a other different